So welcome to this lecture. So I will be taking the lecture of conversational search. And my name is Yifei Yuan, and currently I'm a postdoc at the University of Copenhagen. And previously I obtained my PhD degree from the Chinese University of Hong Kong. So my research interests mostly focus on conversational information retrieval systems, including some multimodal conversational search systems, and some natural language processing tasks, as well as some information retrieval tasks. So let's start with our lecture. Before we dive into more details of how this conversational search actually works, I would like to introduce a little bit more about this general information retrieval evolution. First, let's take a look at different kinds of search. Basically, depending on different search types, we can divide them into three general categories. And the first one is called search on desktop, which generally refers to the process of finding files, folders, or other kinds of data stored on a computer's local drives using a search utility or tool. And it typically contains some really typical search, for example, like web search, desktop search, which typically provides features like indexing, real-time searching, and advanced features to make the search process very efficient and comprehensive. And it also contains something like email search. For example, sometimes we really want to search for a certain email on our desktop using some topics or some keywords. And the second type is called search on smartphones, and it basically happens every day in our daily life. And also in our smartphones, web search is also a very common scenario, right? Because we kind of want to search on the web using our smartphones every day. And it also contains a unique type of search. It's called app search. Sometimes we just want to search for a certain app, like an email app or the Facebook app, using the name of the app or other keywords. And in the smartphone search, there is a very unique type of search called the zero query retrieval that sometimes we don't even want a query to search for something. And in these scenarios, our smartphone just proactively provides us with relevant information through this zero query retrieval, enhancing our daily life. And one typical scenario is that sometimes we really want to know the weather of today, and we just simply open the weather app without any inputs, and the smartphone will return the weather of today using some information cards. And the last type is called search through conversation, which is the main focus of today. I will be basically talking about some multimodal information access, including some image and speech access in this search scenario. Basically, we just use conversations with some multimodal contents inside to interact with the system. And it's often happen in a limited channel. And I will also be talking about LLM-based conversational search, which is kind of like the very much popular research direction recently after the releasement of LLMs. And yes, so let's take a deeper look at this search on desktop. So when we search something on desktop, the first thing is that we might want to input a query into the desktop to search for something. And then the system will return a search result page given the relevance perception of this query and document page. And in this phase, the user and the system have certain interaction, right? Certain behaviors like snippet scanning, result click, page click, and some information cards will be returned. So it's kind of like a back and forth process between the user and the system. And let's take a look at this example, which basically happen every day in our daily life. Like, for example, if we want to search something in the Google search engine, the first thing is that we kind of input a short query into the search engine like dinosaur. And actually, the contents returned by Google search engine is very, very diverse. So first of all, it might contain a so-called information card, like containing some really rough description about the dinosaur. And it also outputs some images here showing different types of dinosaurs, because sometimes we don't really know what kind of dinosaur we are actually searching for. And there are also some lower classifications here showing some pictures of different subtypes of different types of dinosaurs. And the user can just click one of them to go to another page. And besides images, we also have these kind of videos, right? And we can have some videos of different news of dinosaurs. And here there are still some kind of very interesting videos about the news or like the different stories of different dinosaurs. And besides this multimodal information, we also have some relevant textual information of these. People also ask questions here by listing some related questions concerning the concept of dinosaur. And we can also have some searches related to dinosaur, like dinosaur pictures, dinosaur facts, dinosaur names, and whatever. It helps the user, it basically kind of improves the user experience by providing these different types of information and helps the user figure out what he or she is actually searching for in this phase. And the similar scenario also happens in our smartphone. And in our smartphone, we don't really need to use some text-only queries to search for something. And there are always the so-called virtual assistants to help us do this search. And we can use the so-called voice assistants, such as Siri or Alexa, for search on a smartphone. It has become increasingly popular due to its convenience and its hands-free capability. And these kind of voice assistants on smartphones is often very evolving, makes it a really increasingly important part of how users interact with their devices and the digital world. And now we can see, so these kind of recent advances in this ESSIR system, which is the automatic speech recognition system, have significantly widened the capabilities of conversational search, which makes this conversation more important and allow the users to interact with devices using natural and spoken language. And utilizing such advanced neural models and large language models, such as the transformer structures or like LLMs, conversational search has actually achieved remarkable improvements in understanding and processing complex language patterns, which makes this conversational search really, really crucial in this modern IR scenario. And based on different types of conversations, we can actually generally categorize them into 3 different types. The first type is called task-oriented conversation or dialogue. And it often aims to assist users to solve a specific task. That in these type of conversations, the dialogues actually mostly follow a really clearly designed structure that is developed for a particular task in a closed domain. And we mostly have well-defined measurements of this performance that is explicitly related to task completion. And a very typical scenario of this task-oriented dialogue is, for example, the booking system, that the user always want to interact with a virtual assistant system to book a flight ticket or whatever. And we can use some metrics like what is the success rate of such booking to just measure if the system is good or not. And the second type of conversation is called social chat, which is carried on within an extended conversation. And we sometimes also call it chit chat. It's always with the goal of mimicking human-to-human interactions, because sometimes when two humans are talking to each other, they don't actually have a specific topic in mind, and they just do some randomly chatting. And these type of conversations are often developed for unstructured open domain conversations. And they're mostly objected to be human-like, that the system should be able to talk about different topics, both in breadth and depth, in an engaging and coherent manner, which means that it always engage some very frequent topic changes in this type of conversations. And the last type is called interactive QA, which aims to provide concise and direct answers to user queries. That mostly these dialogues are actually unstructured, but they commonly follow a question-answer pattern, and mostly they are within open domain. And we can evaluate this interactive QA with respect to the correctness of answers and on the turn level. And sometimes we also call the third type conversational search because it's always related to information or document retrieval search. And here shows an example of the first type, task-oriented dialogue systems. And we see these task-oriented dialogue systems are interactions specifically designed to accomplish a particular goal or complete a task. And these dialogues often occur between human and systems, such as virtual assistants or customer service bots. And we can see here, these two pictures shows two typical scenarios of these TOD systems. And the left one shows a conversation between a system and the user for booking restaurants. And we can see the user often kind of have some requirements of maybe to find a Chinese restaurant near the center of the town. And the right part shows setting an alarm, and also it contains certain requirements such as remind me this afternoon on 3 o'clock, which means that to interpret these different requirements, the system should be able to extract this key information from the user questions or response. And then this is an example of the conversational search. And for conversational search, the users will interact the system with some information need. And we can see, like, here is the comparison of the conversational interaction between two different users. And they kind of input the same query into the search engine, but with different information need. And the girl on the left wants to look for the Discovery Channel's dinosaur sites with the pictures of dinosaurs and games, but the boy on the right is looking for a list of the different kinds of dinosaurs with pictures. So these information needs are mostly hidden from the user, that the user will kind of try to figure out what the system will try to figure out what the user is actually looking for. So one typical way is that we turn it into a conversational experience that the system kind of asks these so-called clarifying questions in each turn to just interact with the user. So the system will kind of output questions like, are you looking for dinosaur books? Are you looking for meat-eating or plant-eating dinosaurs? And with different information need, the user might provide really different responses to different clarifying questions. And finally, the system can output some retrieved documents to the user to just do this personalized recommendation. And here we can definitely find more examples in our daily life, right? And we kind of have like these conversations happening in smartphones like Siri, Google Assistants, and also in cars. And we can also use some clinical virtual assistants for some mental health. And sometimes we just want to chat for fun without any purposes. And yes, so here are some examples of these conversations. So for example, this example, anyone has any idea what kind of conversation it belongs to? No idea? So if you support for conversational search, could you please raise your hand? So is there anyone thinking it's a conversational search? Seems no. And what about social chat? Is it a social chat? Okay, we have some both. And what about task-oriented chat? Anyone think it's right? It seems most of the people are supporting for the social chat. Yes, actually, it's a good example of a social chat because when interacting with the system, the user doesn't really have a specific goal in mind, just doing some random chit chats. So what about this one? It's a very typical scenario. So what category it belongs to? Is it a conversational search? Any people thinking it's a conversational search? Seems no one. Is it a social chat? What about task-oriented chats? Yes, I think you all get it right. So this one is a typical example of the task-oriented chat because when the user interacts with the system, it kind of have some goal in mind of saying, okay, your credit card ending with is due today with the amount of something. Do you want to pay it? And what about this one? So anyone thinking it's a conversational search? Right. And what about social chats? And task-oriented chats? Yeah, only a few think it's a task-oriented chat. So yeah, it seems most people get it right. So it's actually a conversational search. So the reason is, let's take a look at of this conversation. The user first said, "Hi, I'd like to know about Barack Obama." And then the system kind of outputs some information about Barack Obama. And then the user says, "Tell about his career before being president and show me the early life Wikipedia page." So here in this conversation, the user just want to know some information from the system, but without a specific task. So in this scenario, it's a typical conversational search because the user has certain information requirements, but it's not task-oriented. And then we can provide some definitions that we give the definition of a conversation, which is an interactive communication for exchanging information between two or more participants. For example, like humans or machines that involves a sequence of interactions. While natural language is considered as a prerequisite for conversational interactions, conversations can also exhibit other types of interaction with different characteristics and modalities like click, touch, or gestures. And for information-seeking conversation, it is a specific type of conversation where the goal of information exchange is satisfying the information needs of one or more participants. And we can see an conversational information system, which we often call it CIS system, is a system that satisfies the information needs of one or more users by engaging in information-seeking conversations. And CIS responses are expected to be really concise, fluent, stateful, mixed initiative, context-aware, and personalized. So we can have the definition of a conversational search system, which is basically a system for retrieving information that permits a mixed initiative back and forth between a user and an agent, where the agent's actions are chosen in response to a model of current user needs within the current conversation, using both short and long-term knowledge of the user. And here, when we talk about conversations, there is a concept that we often mention, that is the concept of initiative. And what does initiative really mean? So in a conversation, an initiative refers to the action or behavior that drives the conversation forward, typically by introducing a new topic, asking a new question, or making a suggestion. And following this concept, we can kind of divide the conversations into two different types. The first one is called single initiative conversation, and the second one is called mixed initiative conversation. And for the single initiative conversation, there are two very typical scenarios that sometimes the user has absolute control of the conversation, and sometimes the system has the absolute control of the system. So in the first case, the user has the control of the system, which means the system is passive and only responds to the user's requests. And in the second case, the system has a control of the system, which means the user is kind of passive and only respond to the system's requests. And for mixed initiative systems, it's a bit different, that the user and the system can equally have the control of the conversation, which means that both systems and users can be really active and respond to one's requests. And we can also prompt for one's input using another one's feedback. And if these descriptions are really vague, let's take a look at this example. And if these captions are too small, so let me illustrate. This conversation kind of starts when the user says, "Hi, I would like to know about Barack Obama." And then the systems provide some information about Obama. And the user again said, "Tell me more about his career before being president." And again, the system provides these responses. And then the user says, "Show me the early life Wikipedia page." And then again, the user responds. Do you think it's a single initiative conversation or a mixed initiative conversation? And who is supporting for the single initiative? Right. And what about mixed initiative? It seems we have more votes on the single initiative conversation. And let's take a look at this. So in these three different turns, it seems like the user also often has the lead of this conversation by making requirements like, "I would like to know more about Barack Obama." And the system simply responds by providing these information. But in this case, we can see the system doesn't seem to want to lead this conversation by making questions or whatever. And how about this one? So this is a task-oriented dialogue, right? And the system says, "What city are you leaving from?" And the user just responds. And the system continues to say, "Where are you going? What date do you want to leave? Is it a single, a one-way trip?" And after that, after getting the information from the user, the system just perform the flight booking action. So what about this? Is it a single initiative conversation or a mixed initiative one? Who's supporting for a single initiative? Yes. What about mixed initiative? Is there any vote? Yes, it seems like most people choose the single initiative. And this is a bit different from the previous conversation, right? Because this time the system always kind of make these questions of this information. What city are you leaving from? Where are you going? And in this case, we call it a single initiated conversation because the system is always the one who has control of this conversation. And it seems like the action of the user is to provide the corresponding information by the system. Right. What about this one? So it might seem really similar to the first conversation, but we make a bit change here. Like the first question stays the same. The user said, "Hi, I'd like to know about Barack Obama." And then the system provides some information here. But after that, the system says, "Would you like to learn more about Barack Obama's family life, career?" And the user says, "Tell me more about his career before being president." And after that, the system again outputs some information. And is there anyone think it's a single initiative conversation? What about mixed initiative? Yes, we have some votes. Yes. And we can see, even if we just make a really simple modification here, it kind of change the experience into a more mixed initiative one, because in the first turn, the user initiates the conversation, and after that, the system just responds. And so specifically in this turn, the system asks for feedback, which tries to be the initiative of this turn. And after that, the user provides feedback, and the conversation continues when the system responds. And we can see the system and the users both become the initiative and try to take the lead of this conversation in this example. Okay, right. That is basically most of the definitions we have in mind. And in the next section, I will be talk a little bit more about how this mixed initiative conversation actually works in the conversational scenario, because basically it seems it's more advanced and more superior than the single initiative conversations, right? And let's retake a look at this example. We will see from here. In this turn, the system actually tries to take the initiative by asking a question. And normally we call this type of question as clarifying question. And for clarifying question, it is often generated when the original request is really incomplete, and it can be interpreted in various ways. And instead of returning bad results, sometimes we just require the system to ask clarifying questions to understand the intent. For the voice-based and chatbot, it kind of requires open answer to the system's question. And for the web search, we kind of provide different multiple choices within the clarifying question. And there are two very important research questions concerning this asking clarifying questions. The first one is, it's very important for us to figure out when to ask these clarifying questions, which means that we may need or design certain mechanisms to just perform clarification need prediction. And the second task is that what to ask in terms of these clarifying questions, which means we might design some clarifying question selection, retrieval, or generation module to help us pick the most suitable clarifying question to ask. And here, we provide 3 different examples of these clarifying questions. The first one is, the user said how to write a thank you letter after an interview. And then the system said, are you interested in example of thank you letters for interview? And the user says yes. And after that, the system provides a few examples about how to write this thank you letter. And we can see, so basically in this conversation, there's actually no need for these clarifying questions, right? Because what the user is asking for is already very, very complete, and it kind of causes no ambiguity or some misunderstanding. But things get a little bit changed in this example. And when the user said, tell me more about the source of the Nile, the system said, are you referring to the Nile River? And the user then goes, no, the board game called The Source of Nile. And in this case, we can see these clarifying questions is needed to eliminate wrong answers. And sometimes when the user says, okay, I'm looking for information on Jack Chemical Company, and the system just want to double check and make sure, are you interested in a specific type of product? And the user goes, yes, surface treatment products that Jack Chemical Company manufactures. And here, these clarifying questions is needed to return a right answer. And how does this clarifying questions actually work? So let's take a look at this picture, which tries to illustrate how can we output these clarifying questions using some algorithms. So it's like the general paradigm is that the user tries to interact with the system. And first of all, the user goes, I'm looking for information on Jack Chemical Company. And after that, this information need is fed into some user understanding request module. And after that, the system kind of judges if it needs clarification or not. If yes, it goes here to a question generation module that some clarifying questions are generated here. For example, we can generate a question like, are you interested in a specific type of product? And based on this clarifying question, the user provides the corresponding responses like, yes, surface treatment products that Jack Chemical Company manufactures. And after that, we feed this answer together with previous turn into this user request understanding module again to just do another round of classification, whether to generate a clarifying question or just provide the corresponding response of here's the information about their products. So this is basically how the user interact with the system in each turn. And we can see here, it's actually a multi-turn conversational experience in this example. And we can, of course, using some evaluation pipeline to evaluate how good the system is in this scenario. That we can start from crowdsourcing single-turn conversations, and of course, perform training or evaluation on these dialogue agents. And if we want to move it in the next step, we can crowdsourcing multi-turn conversations and perform human evaluation. To make this into reality, actually, there is a data set called ClariQ, which contains a lot of clarifying questions, which was released before. That it was kind of basically released for the CompAI3 data challenge, and it can be used for this automatic evaluation or human evaluation. And it contains a lot of mixed initiative conversations, and it can also be used for some downstream tasks like document retrieval. And we can, of course, borrow some metrics to do some automatic evaluation. And it's based on some external data sets called ClueWeb dataset. And it's actually a common web crawl data set with 50 million documents. And it's designed for some ad hoc retrieval and diversification tasks that was used in the track web track. Yes, so this picture provides some an overview of how this data set actually looks like. That with a single query like dinosaur, it contains different facets of discovering channel, dinosaur pictures, dinosaur books, and each represents for the corresponding user intention. And for each facet, we kind of attach different topics, different documents here to facilitate this document retrieval. And here we assume that each user is interested in one facet per topic, which means that the girl here may be interested in the discovery channel facet, and the boy here may have the user intent of these dinosaur pictures, and the man here is, we assume the hidden information need is the dinosaur books. And for each of them, we kind of have some ground truth document annotations here to attach the corresponding documents for each of the facets. And let's wrap this up a little bit in a mathematical way. So this shows a offline evaluation methodology of such evaluation. Like, first of all, we have a collection of T, which contains T1 to Tn, be the set of topics. And we also have a collection of facet sets. F contains different sets of facets where each Fi represents and includes all the defined facets for topic Ti. And we also have a collection of clarifying question sets, Q, where each of them, Qi, includes all the clarifying questions relevant to topic Ti. And based on all the information we have, we can train an offline evaluation that requires, given the topic T and the facets collection F and the clarifying question collection Q, we train this model or this function to generate the corresponding answer A. So basically, we borrow all this information of T, F from this clue web collection and attach it in our data sets. And we just collect these clarifying questions from scratch and put it in the ClariQ data sets. So having this function A, we can perform such automatic evaluation. And there are different levels of evaluation we can take a look into. First of all, we can definitely evaluate in terms of the clarification need. That's how vague a query is. And some metrics like MSE, precision recall F1 can be used for this kind of evaluation. And we can also evaluate from the level of question relevance. That's how many relevant questions are retrieved from the question bank. And here we can use the recall at K to just evaluate the question relevance. And in terms of document relevance, we have to know how much does the selected question help improve the retrieval performance. And we can use some IR metrics like MRR, precision at K, and DCG to just evaluate the system on this level. And of course, we can use some human evaluation that we can hire some human annotators to judge how good a conversation is. And mostly we just do this pairwise comparison that we compare to competing systems. And for example, we compare the conversations from mixed or single initiative conversations, and we kind of evaluate from the correlation with automatic evaluation. And in terms of human evaluation, we can take a look at different aspects like engagement, knowledgeable, interesting, human-like, or we just take a look at the quality of these clarifying questions to perform such evaluation. So in conclusion, in the evaluation of these conversations, because the conversations are mostly very complex, and we can definitely have various possibilities from the user reviewment, system reviewment, chit chat, set retrieval, or whatever. And it's often limited in certain bandwidth with small pieces of information can be communicated, and we can perform some evaluations in mixed initiative conversations or some evaluation on the system strategies. Right. So this is mostly about the mixed initiative conversation. And before we take the break, I'm gonna talk a little bit more about this multimodal query clarification. And the basic idea is that we want to incorporate some multimodal information in the query clarification phase and make it more interesting to the user. And let's retake a look at this example. And when we try to search for something like dinosaur, in the search engine, we actually kind of use a simple query like dinosaur. And if we retake a look at all the contents returned by a modern search engine like Google, we will find these contents are often not text only, which means it contains some multimodal information to make this interface more interesting. It also it often contains information like these videos or like these information cards containing different images to help the user, to improve the user experience and to help the user understand what he or she is actually searching for. And we want to mimic and formulate such phase of incorporating multimodal contents into this clarification search process, that we kind of define a task of multimodal contents in query clarification. And we assume and hypothesis that compared with text-only clarification questions, multimodal clarification questions can sometimes cause better understanding of the user intention with increased retrieval performance and higher user engagements. And we provide an example here actually, like For example, when the user wants to search something, for example, like bike repair from the search engine with the information need, repair the bike with chain skipping problem, we kind of compare two conversations here. The left one does not have an image and the right one has an image. And we see in the left conversation, the system kind of asks questions like, which part of bike are you going to repair? But sometimes the user himself does not sure which part actually goes wrong, right? And sometimes the user has no idea which parts is contained in the whole in the bike structure. But what if we provide images in this process? Like, for example, the system asks, which part of bike are you going to repair, by attaching an image of different components of bike here. So in this case, the user can say, okay, I think the problem might be in the chains because it keeps skipping between gears. And once again, the system goes, can you try changing a chain ring by showing a picture of how to change this specific part? So the user can say, okay, I just did that and it works. So we see in this type of scenario, if we add images, it kind of causes better understanding of the user intention, and we can basically have increased retrieval performance in this scenario. So in this case, we define sometimes, yes, we can add multimodal contents in query clarification, right? And we kind of want to define a pipeline of how this actually works. And the pipeline goes here, like it starts when the user submits a query into the system and into some information need representation. And after that, the system performs some document retrieval. But sometimes when the query is too short or too ambiguous, the system might not want to present the result to the user. So it goes into the so-called question clarification here, that some clarifying questions are retrieved. But after that, if we want to make this process multimodal, we kind of judge, we judge whether to add images into this question. And if yes, we perform some image retrieval to attach an associated image into the clarifying questions. And after that, the multimodal clarifying questions will again be demonstrated to the user, and the user will provide the corresponding answer. And once again, it will be fed into some information need representation module and do the document retrieval once again. And this time, the system is provided with some additional information, and with this additional information, the results will be improved. So maybe this time is a good time to just demonstrate these retrieval results to the user. And to make this happen, we also collect a data set called Melon, which is basically the first large-scale clarification data set with multimodal information. And we kind of collect the clarifying questions either from ClariQ or from Scratch. And we also attach 3 images to each clarifying questions. And we kind of design a model to just train the model. That it consists of 3 different modules, which corresponds to different stages in a multimodal clarification search system. And in general, we just adopt a generated framework and fine-tune different subtasks with different task prefix. And in our experiments, our first research question is that, does adding this multimodal information actually helps the retrieval results? And we kind of take a look at these experimental results. And we see when we try to compare visual birds with its text-only counterparts birds, the performance got improved. And when we try to compare Marto, which is our model based on the multimodal version of T5, with the text-only T5, the performance also gets improved. So our conclusion is, yes, adding these multimodal contents really helps to improve the retrieval performance. And we can definitely have have other very interesting findings from this table that when we try to compare these models with its counterparts, that we basically remove the question classification module, which means that we remove the module to determine whether these clarifying questions are multimodal or not. We find the performance actually decreases, which means that this classification, which means that classifying the questions into either multimodal or unimodal really helps the process. And another interesting finding is that when we try to compare models with a compact structure, that basically we use one single base model to perform different stages of fine-tuning. With these pipeline-based models, we see the performance of these compact models actually have better performance than these pipeline-based models. And of course, we try to also compare with these generative models with discriminative models. Like if we compare T5 with BERT and our model with Vischer-BERT, we also see these generative IR frameworks have better performance than these traditional discriminative ones, which makes more room for these LLMs. For example, we can use Llama as a backbone to perform such generative retrieval. And we also find it's very interesting that attaching the right image actually matters in this phase, that we try to attach different images with these clarifying questions by some random image or like some topic relevant image. And we find it really has a big influence on the overall retrieval performance, which means we should design a more appropriate method for attaching these images into these clarifying questions. Okay, I think it's time for us to have a break of 10-minute break. Maybe you should come back at 12 and I will continue our next section. And if you have any questions, please just come to me. Let's continue our lecture and move on to our next section of LLM-based conversational search. So before we get started, let's briefly take a look at the history of this conversational AI. Basically, we can divide this conversational AI history into 3 different phases. In the very first beginning, everything is really rough, and we see it's mostly based on some rule-based techniques. And basically, around the year of 1966, we kind of design some rules to perform these rule-based chatbots. And after that, it moves on to the machine learning era that some machine learning techniques have already been released. And here we can see we use the rule together with the machine learning techniques to perform the search. That includes some products like Amazon Alexa and other products we are currently, maybe we used in a few years ago. And after that, after the success of transformers, it has been moved into the transformer era, which means there's it always contains a larger model with a larger amount of data. And after the success and releasement of these large language models, we kind of move into the deep learning era. And from here, we see in 2021, we have a specific chatbot, which is based on the transformer with 1.75 trillion parameters. And moving on to 2022 to now, and we see some state-of-the-art products like ChatGPT, Google Bard, and ErnieBot are based on these large language models, which means it usually contains around hundreds of billions of parameters here. So this means it becomes more and more important in this LLM-based conversational search system, right? And when we look back between what we've already known before, like there are different types and typical applications of conversational systems, like open domain dialogue systems, task-oriented dialogue systems, and conversational information seeking systems. And if we're gonna take a look at these conversational information systems, we kind of can find different applications like conversational question answering systems, conversational recommender systems, and conversational search systems. And in my next a few slides, I will be talking about some basic LLM applications in all of these different types of conversations. And so let's start with these open domain dialogue systems, which we also call it chit chats. They are designed to simulate natural human conversation by engaging conversations without any specific domains. And we see here shows an example of such a conversation. And we see from here, the conversation evolves between two persons, each with a different persona. And with this personal information, it kind of represents the different characters of one person. For example, like the first person, he likes to ski, but his wife does not like him anymore. And he has went to Mexico 4 times this year. And for the second persona, it shows the person is an artist and has 4 children. That at the beginning of this conversation, person 1 is given their own persona at the beginning of the chat, but does not know the persona of person 2 and vice versa. And they have to get each other's persona by interacting with each other within this whole conversation. And of course, there are different applications of how we can use LLMs in this open domain dialogue chit chats. That we can first of all use it for personalized response generation. And here shows an example of how this actually works. And we see we kind of input some candidate personas here to the system, and the system will perform some personal retrieving by retrieve some candidate personas here. And after that, the LLM will select a persona here and provide the corresponding response according to the input persona. Like, hi, are you feeling better from your cold? And after that, the user will interact with the system by saying, okay, I'm completely over my cold, thanks. And in the next turn, another persona is either selected for another response, or the LLM just sticks to the current persona and provide more responses like, good to hear, what are you up to? And these types of scenario often happen in some emotional support dialogues that the LLM aims to provide more supportive responses based on the persona of a user. Of course, we can also use LLM for a conversation generation, which means we can use it to generate these conversations from scratch. And one possible way of doing this is that we can fine-tune a language model using some dialogue samples in an autoregressive language model. And after that, we can perform such dialogue completion that we kind of provide a starting utterance here to the language model, and the rest of them are completed by a LM. And the third part is called post-processing. Like, we just abandon some unreasonable conversations generated by LM and just keep the reasonable ones here. And this technique is often used in this so-called data augmentation process, because sometimes it will be really time-consuming and costly for us if we want to hire someone to just generate and write these conversations from scratch. And from the perspective of dialogue evaluation, we can also leverage the LLMs to perform the so-called dialogue evaluation. And the basic idea is very simple. So here shows an illustration of how this might work, which leverages a unified multidimensional evaluation schema and a single prompt to efficiently evaluate open domain dialogues with large language models. And we see we can provide this LLM with an example conversation here. And we define some metrics like appropriateness, contents, grammar relevance, and we ask these LLMs to do such judgment. And for end-to-end task-oriented dialogues, so it is often decomposed into 3 different tasks. The first task is called user input understanding, and the next task is called action decision, and the third task is called response generation. And here shows an example of how we can possibly train these 3 different tasks into in an end-to-end way, because in the very first models, we kind of use some pipeline-based structures and train 3 separate models for each of these tasks. But later, people think maybe we can just put them all together into one generative model, and we can fine-tune it with different prompts. And this is basically the idea of this model called simple TOD, which is a very simple approach that adopts a single language model trained on all subtasks, react as a single sequence prediction problem. And we can see here, when training the model, we just use different tasks and we train the model to generate these different utterances. And when we perform the inference, the basic idea is that we kind of ask the model to generate 1 token at a time and add the generated tokens to the input sequence for the next step of generation in a really auto-regressive manner. And we kind of differentiate these 3 different tasks using 3 different prompts, and so that we can kind of combine them in one single structure. And it also paves the way for the LLMs that sometimes we can use these LLMs as a backbone to just to perform the pre-training and fine-tuning, like we can use Llama instead of T5 or BOT or whatever. And we can also use some LLM-based end-to-end TOD. And sometimes we don't have to do the fine-tuning, and we can just do some instruction tuning or prompting. And this model actually shows a basic idea of how it actually works, that it is the first zero-shot end-to-end task-oriented dialogue system that requires no task-specific annotations. The basic idea is that they generate a so-called proxy belief state here from the dialogue history, representing everything that the user is actually looking for. It's in the natural language format. And to interact with the KB, which is the knowledge base, an action thought here is generated. And we can see we generate an action thought like look up the KB for names, addresses, and price fancy. And after that, we turn this action thought into a KB query, and we look at the KB and have the outputs. And then the output from the KB is then passed by the LLM to extract relevant information, which provides a summary of the KB interaction. And it also determines whether the current action thought has been fulfilled. For example, sometimes maybe at the end of this action, it fails saying, I couldn't find fancy in the price range attribute of the KB. And it's kind of like a reflection of such phase. If it remains unanswered, a new action thought is actually generated again in the second iteration. And the process repeats until a stopping criteria is reached, indicating that no relevant knowledge is found in the KB. So this is basically like a method of how can we just simply using this LLM without any fine-tuning to solve this end-to-end TOD problem. And it's actually very convenient because all you have to do is to prompt the LLM and to provide these feedbacks at each turn. And you don't really have to use some GPUs to do this fine-tuning. And it also works in these conversational information seeking systems, that for these conversational information seeking systems, it's often partitioned into 3 applications, which contains conversational question answering, conversational search, and a conversational recommendation. I will just briefly talk about how LLMs can be leveraged in each of these tasks. And I think for this recommendation, problems, we have another lecture, which will give you a more detailed explanation of how this might probably work. So for conversational question ranking, so let's take a look at this example. So this shows an example of the famous Quark dataset, which focuses on a simple conversational question answering tasks. And the basic idea is that we kind of provide a title and the corresponding context passage and give it to two human annotators. And we form it as a reading comprehension task. So the first annotator is called a student annotator, which aims to provide a question associated with the context passage. And the second human annotator is called the teacher, which aims to answer the question raised by the student using the background knowledge within the context passage. And in each turn, the student and teacher interacts with each other in a way that finally we will have a multi-turn conversation here of this conversational QA process. And so one of our idea is that can we leverage LLM to simulate such phase? And what is the difference of this LLM generated conversation compared with human generated conversations in Quark? And the basic idea is that we kind of also adopt two LLMs, one as the teacher and one as the student to interact with each other. And in detail, we provide a Wikipedia page to each of the teacher and the student LLM, and we kind of instruct the student LLM to perform such question generation to generate the corresponding question from the Wikipedia page. And the teacher LLM is supposed to answer the question generated by the students using the information in the Wikipedia page. And we perform such comparison between LLM-generated conversations and human-generated conversations from different perspectives. That first of all, we take a look at of the answers generated by both of them, that we fix the question here, and we only evaluate the LLM-generated answer and the human-generated answer. And we see, like here in this table, we see basically almost 30% of them have overlapped, and almost half of them are completely different, and only 20% are exactly the same. And we also hire some human annotators to just judge these two different conversations within the metrics of correctness, naturalness, and completeness. And we see most of the cases, the LLM-generated answers win the human-generated answers. And we also ask them to just pick the one they prefer. And it's really surprising that almost 90% of these humans pick LLM-generated answers as better answers. And we also want to look at them in the conversation perspective, that we kind of compare these LLM-generated conversations with these human-generated conversations. And here shows an example of these two conversations. And we can always find these LLM-generated conversations seem to be longer and more complete. And we try to take a look at it by the topic coverage, and we find LLMs actually can provide conversations with a wider range of topics, which means that when we try to instruct these LLMs to interact with each other, it kind of provides more information, and sometimes it's more related to the Wikipedia page compared with humans. And it kind of gave us some inspiration of how these LLM-generated conversations is different than human-generated conversations in the conversational QA context. So in the conversational search context, we can also use these LLMs to provide to just perform some specific tasks. Like one typical task is called conversational query rewrite, which aims to convert an in-context query into the fully specified form given its context. And often the main research challenge in this CQR task is called coreference resolution and ellipsis completion, which means some information may be co-referred or omitted in previous turns. Like here, if we take a look at this table, we can see for the second question here, what are some other facts about her voice? Actually, the term her actually here in the original query is resolved as Beyonce in the rewrite, right? And in the third turn, the omitted information after the term what else is completed after rewriting. And most traditional methods just train a sequence-to-sequence model, which takes the conversational history as input and fine-tune them to just generate these query rewrites. But it can contain certain limitations. Like, first of all, it's really hard for us to just collect these conversations with the gold rewrites, which means we will have to hire a lot of people to just manually perform the rewriting. And another very important issue here is that sometimes different people may have different writing styles of these rewrites, which means, for example, when we try the model and train the model on one data set and test it on another data set, the performance drop is very severe because the model kind of lacks some generalization ability. So the basic idea here is that we can use some generative frameworks to perform the so-called co-training. And the co-training process is that it consists of a rewriter and a simplifier with dual nature. And the function of the rewriter is that it generates the fully specified rewrite based on the original in-context query, where the simplifier works the other way around. And the rewriter is a final model we eventually want to have, and it's the only model in the inference phase. And so as shown in this figure, the whole paradigm is contained in a so-called co-training loop, where the simplifier and rewriter are trained together. That the paradigm can be divided into different main steps. And the first step is that we can use a small portion of labeled data to both warm up this rewriter and simplifier at the same time. And after that, we kind of maintain two different unlabeled data sets that we perform the so-called Sybil labeling to just perform the inference of rewriter on and simplifier on their corresponding unlabeled data sets and do this labeling. And in the next iteration, we can see from here, the Sybil labeled data together with the original small portion of labeled data can be together used to train the model again and to improve the model in the next iteration. And the basic idea of this co-training paradigm is actually very simple. It's just to leverage the simplifier in a adversarial way to improve the ability of the rewriter. And so which means the simplifier only transforms the fully specified questions into the simplified original in context version, and it's like it's trained to help to make this rewriter more robust. So we kind of test this paradigm onto different data sets, and we find compared with traditional fully supervised methods and also self-learning methods, this co-training paradigm actually helps a lot in both of these data sets. And we can definitely try different backbones of the so-called co-training paradigm. Like in our original version, we use GPT-2 as our backbone. And after that, we upgraded into the llama-based co-training paradigm. And we see there's also a performance boost compared with GPT-2-based method. And we can, of course, try more advanced, more state-of-the-art large language models like Llama 3 or Mistral to make it more advanced and has better generalization ability. And another question is, can the results be further improved in this paradigm? And we try to take a look at it by using a larger amount of unlabeled data with high threshold, which means more higher quality of the Sybil labeled data is filtered in this co-training paradigm. And we find the performance can be further improved in this case. So this shows an example of how we can use these LLMs to have better generalization ability when training some traditional IR tasks. And of course, it can also be leveraged into these conversational recommendation systems that basically the idea is that we can either take the LLM embeddings and to feed it into a recommender system to have better performance, or we can just extract the tokens by the LLM and feed it into this RAS system, or we can just simply rely on LLM to just perform some instruction tuning and directly use the generated response as the final recommendation results. Right, and of course, we can both use some discriminative LLMs and generated LLMs to perform such recommendation. And since we don't have enough time here, I'm just gonna skip a little bit. But the basic idea is that so the results of these LLMs and of course the features of these LLMs can be used for a better recommendation results. Right, and the last section is called user simulation, and it's actually a very common technique in this conversational information retrieval context. And it becomes very important because we always have a lot of evaluation challenges in these conversations because these conversations are mostly limited to a predefined set of questions. And most of the time, human in the loop is very expensive, and it's very hard for us to just scale up this process. And also human annotation is also very expensive. It's also very impossible for us to just scale. So the basic idea of this user simulation is to train a model to simulate and interact with the system as a real user. So there are a lot of techniques to do this, but the basic idea is that in this simulated user method, we kind of use some NLU modules to understand the conversation context, and we kind of need some response generation techniques like planning, execution, and learning, so that we can train a better user model. And after that, we will use some NLG techniques to generate the corresponding response given the conversation history. And the basic idea of this code searcher is it kind of generates yes or no response to this conversations. And of course, we can improve it to generate more sophisticated responses and not limited it to yes or no. For example, here, so these simulated users will do this querying, question answering, and feedback providing in terms of the conversational system when it asks clarifying questions or process answers and providing response. Yes, so basically, we can also use these LLMs in this user simulation that we can do few shot prompting with some GPT, or we can also use it as a multi-turn simulation method, and of course, improve retrieval performance by providing explicit feedback. And yes, so this is the summary of today's lecture, that first of all, we kind of define different types of conversations, and we introduce the definition of conversational information seeking system. And after that, several evaluation paradigms are introduced. And also, we kind of have some better idea of how this mixed initiative information seeking system work. And after that, we introduce a little bit more about LLM-based conversational search, as well as user simulation. Okay, I think we are already reached our time limit. So if you have any questions, please just reach to me.